Welcome back. In this video, I will teach you the fundamentals of data visualization in R. By the end of this video, you will have a solid understanding of data visualization and how to turn raw data into meaningful insights. We will explore why visual representation matters and how to choose the right chart types and how aesthetics can enhance your visuals. You will also learn practical how techniques such as creating layered and customizable plots with ggplot2, a data visualization library in R, and using base graphics for quick and effective exploratory data analysis. I will guide you through a hands-on workflows that includes exploring your data sets, selecting the best plotting methods, and fine-tuning your visuals with essential customizations. With these skills, you will be well equipped to transform complex data into clear and actionable insights. Now, what is data visualization? Data visualization is both an art and a science. It is the practice of representing data through graphical means such as charts, graphs, and maps. By transforming numerical or textual information into visual formats, we uncover hidden patterns, trends, and insights. This process breathes life into raw data, turning abstract numbers into compelling stories that are both easy to understand and share. Let's see the impact of data visualization in the real life world. Data visualization plays a pivotal role in analytical process for several key reasons. One, it simplifies complex data. Large data set can be overwhelming when viewed raw. Visualization distills and structured data, making it immediately comprehensible. For example, a well-crafted line chart can succinctly illustrate time trends that might be lost in a table of numbers. Two, it reveals patterns and trends. Visual tools help us understand relationships such as correlations or trends, which often lead to new insights and hypotheses. A scatter plot, for example, may uncover a possible relationship between study hours and exam scores. Three, it supports decision making. Clear visual evidence provide a persuasive basis for conclusions and recommendations. Well-designed dashboard, for example, can quickly highlight key performance indicators enabling informed decisions. Four, it engages the audience. Visual capture attention far more effective than raw data. They help make presentation more persuasive and ensure that complex information is accessible to all audience. The last but not the least, it facilitates communication. Good visualizations transcend language barriers, offering a common visual language that simplifies the communication of intricate ideas. Now, let's see different ways at which we can choose the right visualization. Selecting the right visualization type is crucial for effective communicating your data stories. You start by defining your objective. You decide if you need to compare the values, illustrate the composition, and understand distribution or analyze trends. Next, you take a closer look at your data. You determine whether variables are categorical, numerical, or time series, and then you identify whether you are focusing on relationships, distribution, or outliers. It is also important to know your audience. You tailor your visualization to their background and expertise so that it strikes the right balance between being too complex or too simplistic. Also, you need to consider the practical constraints such as presentation medium, whether it is digital or print or verbal, and evaluate the quality and quantity of your data. Remember that large data sets might require aggregation and any limitation that could influence your visualization choices. Additionally, you pay attention to aesthetics and clarity. Use color, shape, and size thoroughly to enhance understanding without overcrowding your visual. Lastly, always ensure that your data visualization ethically represent the data and accurately reflecting the information without misleading your audience. Now, let's see different types of visualization that we have. Data visualization techniques can be classified into three categories, each offering a distinct lens for interpreting data. And we have univariate analysis, bivariate analysis, and multivariate analysis. Univariate analysis involves examining a single variable to understand its distribution, sector tendency, and spread. For instance, you can construct a histogram to explore the age distribution within population, which reveal patterns such as skewness, clustering, as well as presence of outliers. Univariate analysis involves examining a single variable to understand its distribution, center tendency, and spread. For instance, constructing a histogram to explore the age of distribution within a population reveal patterns such as skewness and clustering, as well as the presence of outliers. Bivariate analysis involves investigating the relationship between two variables. For example, a scatter plot can be used to explore the correlation between advertising spend and sales revenue, highlighting trends, cluster, and potential causal relationship. Multivariate analysis involves the simultaneous examination of three or more variables to understand complex interactions. Techniques such as bubble chart or parallel coordinate plots allow you to evaluate factors affecting customer satisfaction by considering service quality, price, and brand reputation all at once. Understanding which type of analysis to apply helps guide the selection of the most appropriate visual techniques to extract meaningful insight from your data. There are a lot of common data visualization techniques, but mastering a few core techniques will equip you with essential tools for most analytical needs. Let's now explore some of these visualization techniques. A bar chart represents categorical data using rectangular bars, where the length of each bar is proportional to the corresponding values. Bar charts are ideal for comparing values such as sales figures for each month, student enrollment numbers for each department, or survey responses for each region. In a bar chart, categories are typically shown on the x-axis while the values appear on the y-axis. The bars are spaced apart to emphasize that the data is discrete. A bar chart will have the following dimension: length, that is what we have in the y-axis; the category is what we have in the x-axis; and the color, we can colorize each of these categories. Histogram has the following visual dimensions: bin limit, that is what we have in the x-axis; the count or the length, that is what we have in the y-axis, which represents the frequency of each bin. Then we have color. We can choose to color our histogram with any color. Next chart is the circular chart. Circular charts such as pie or donut chart represent numerical proportion in a compact format, with each slice corresponding to a category's contribution to the whole. Circular charts are ideal for displaying data where the total represents 100%, such as market share, budget allocations, or survey results. In a circular chart, the entire cycle represents the data set, and each slice size is proportional to its contribution. Donut charts provide additional center space for extra labeling. Please note that circular charts may become challenging to read when there are many small or smaller slices. In such cases, consider using a bar or a stacked chart for better clarity. In a circular chart, we only have one visual dimension, and that is the color. For example, each slice is represented by different color. The next chart that I would like to consider is the scatter plot. Scatter plots use Cartesian coordinates to display the values for two numerical variables, with each point represent an observation. Scatter plots are perfect for examining relationships, such as the connection between the study hours and exam scores, or between advertising spend and sales revenue. In a scatter plot, one variable is mapped to the x-axis and another variable is mapped to the y-axis, with data points plotted in two-dimensional space. Trend lines like regression line can also be added to highlight overall relationships. In a scatter plot, we have the following visual dimensions. One, the x-axis, that is what we have here. The y-axis is what we have here. The shape, as you can see, we have a circular shape here. Then color, we may choose to represent this point with a color. Then we also have size. As you can see, the shape here is having small. If we are also making another variable for this size, and then this this point here will be by that weight of that variable. The next chart is the box plot. Box plot summarizes a data set by displaying its median, quartiles, and potential outliers along a number line, making them especially useful for comparing distribution across categories. Box plots are ideal for comparing test costs, salary spreads, or delivery times. In a box plot, the box spans the interquartile range from Q1 to Q3 with a line inside representing the median. The whiskers extend the minimum and maximum values within 1.5 times the interquartile range, and any outliers appears as an individual point outside this range. Here is a box plot. This place is the minimum, that is where we have at the whisker point. Then we also have the first quartile. The first quartile is what we have here under this box. Then we have the Q3. The Q3 is also at the upper edge of this box. Then we have the median. The median is what we have here. As you can see, it's always at the middle of that box. Then we have the maximum. The maximum will be under this whisker. Then we now have the outliers. Then the outliers can be above the maximum or below the minimum. For example, here is the outlier, is here, which is below the minimum. If we also have another outlier, it will be maybe here, above the maximum. Then we also have the interquartile range. The interquartile range is the difference between the third quartile and the first quartile. You just subtract Q1 from Q3, and that gives you the interquartile range. Box plot also have these visual dimensions, the x-axis. As you can see, it can be here, and then the y-axis is what we have all this value for this dimension: the maximum, the Q3, the Q1, the minimum, even the outlier. So all this you can get their values from the y-axis. It's also possible to display the box plot either on vertical axis or on the horizontal axis. For example, this one here is on the vertical axis. If you have another one, it will be like you are interchanging all of these to be on the horizontal axis. I will show you when we move into the practical section. Another plot that I would like us to consider is the line chart. Line charts display data points connected by straight lines, making them ideal for visualizing trends over time. Line charts are perfect for tracking changes, comparing time series, or showing continuous progression. In a line chart, the x-axis represents the time or the sequential data, while the y-axis displays the quantitative values. And multiple lines can be used to represent different categories. In a line chart, we have the following visual dimensions. We have the x position, it is always represented in time. Then we also have the y-axis, that is what will be here. Then we have the shape. The shape could be how you want this line to be represented. We have the color. As you can see here now, the line chart is having a blue along its line. Then we also have the size, that is how thick you want this line to be. Area charts are ideal for showing cumulative totals, visualizing part to whole relationship, or comparing quantities over time. In an area chart, the x position, this is what holds the time. Then we have the y position, which is here. Then we also have the color. As you can see, now this one is having two categories. We have the category for origin, and we also have the category for destination, and each is visualizing using different color. Now that you have understood the fundamentals of data visualization, now let me teach you the theory behind ggplot2. R offers several graphic systems, but ggplot2 stands out as one of the most elegant and versatile tools for creating high quality visualization. As part of the tidyverse, ggplot2 is built on the principle of grammar of graphics, a systematic framework for constructing graphs. This approach allows you to map data variables to visual properties in a coherent and flexible manner. At its core, the grammar of graphics deconstructs a visualization into the following key components. Number one, data. That is data set to be visualized. For example, your data frame. 2. Aesthetics. Aesthetic mappings describe how variables in the data are mapped to visual properties or aesthetics of geoms. For example, x, that is the variable on the x-axis. We have the y, that is the variable on the y-axis. We have the fill, this fill color for shapes. We have the color, this color points and lines. We also have the size, that is the size of the points. We also have shape, that is the shape of the point. We also have the graph. This identifies series of points with a grouping variable. Then we also have facet. This creates a small multiples. And as you can see, all of this is what we have in the aesthetics. For example, you can see x, and that is where you put your variable. We also have the y, that is where you put your y variable. And the fill, if you want to fill so that it can color the shapes, then you have it here, and so on. Then 3, we have the geometric object. This is the visual blocking blocks that represent the data point. For example, we have the geo point. This helps you to create a scatter plot. We also have the geo smooth. This add trend lines across the scatter point. This is what we call regression line. Then we also have the geo bar. This helps you to plot a bar chart. Then we have the geo curve. This also helps you to plot a bar chart but using the pre-computed values. Then we have the geo histogram to plot histogram chart. Then we have geo box plot. This helps you to plot a box plot. Then we have geo violin. This helps you to create another version of box plot called geo violins. You use geo violin when your data is actually very large. Then we have geo freak poly. This helps you to plot a frequency polygons. Then we have geo line for plotting a line chart. Then we have geo area. This helps you to plot area charts. We also have additional layers that enhance or modify your plots, allowing you for customization and refinement. For example, we have the start layers that perform statistical transformation. Then we also have the scale. This control how data values are mapped into aesthetic values, including axes, ranges, and color gradients. Then we also have the coordinate system that define the space for plotting. For example, we have Cartesian, we have polar. Another layer that we have in ggplot2 is called facet. This creates a multiple panels by splitting the data based on one or more variables. We also have themes. For example, you can customize non-data elements like backgrounds, grid lines, and text in ggplot2. Then we also have labels. This one helps you to add titles, axis label, legend, or annotations. Now let me show you how to build plot with ggplot2. To create a plot using ggplot2, you will begin with the ggplot2 functions, specifying your data and aesthetic mappings inside this function. Then you continue adding layers by using the plus operator. For example, you may have it like this. As you can see, we start with ggplot2 function, and in it we have the argument for data. So this is where your data frame will be, and then we have aesthetic mapping under this AES function. Then you continue putting all how you want to map your data. For example, the X, the Y, the fill, the color, and many more. Then you continue with this plus operator to add geoms and other layers. For example, when I put plus here, then this one will now be the geom that I want to use. Is it geom bar? Is it geom box plot? Is it geom histogram? And so on. Then you continue by also adding plus with other layers. Other layers could be the theme, the label, and many more. Alternatively, you may want to use the pipe operator, and this is how you will do it. You will start with the data, that is your data frame. Then you pipe it. Then you start with the ggplot2 function. Then inside it, you put your AES mappings, the x-axis, the y, the fill, and many more. Then you continue by adding the plus operators. Please note that you will not use the pipe when you are supposed to be using the plus sign, because the plus sign will help you to add the geom and also add other layers, not the pipe operator. We only use the pipe operator so that we can have it in a straight path. And as you know that I've already taught you how to use pipe operator before. That is why I'm introducing it here, because other R programmers also do it in this way. They start with the data, then they pipe it, then they start with the ggplot2 function, and inside it they use the AES function for the mapping, and then they now continue by using the plus operator. Now let me show you how to create a scatter plot using ggplot2, and that follows the grammar of graphics semantic component, which are these. As you can see here, we have the scatter plot using ggplot2, and the first function is our ggplot2, right, followed by the data, and here is our data frame. Our data frame is the empty cast. Then here is the mapping, and we start it with AES function. From here we have x, and here now takes our x variable, that is the display. Then we have y. This one will take our y variable, that is the mpg. And after that, then we start with the plus operator, and then we use our jump. In this case, because we want to plot a scatter diagram, then we use jump point, and that gives us this. And here is the format that it follows, which we call semantic component. As you can see, ggplot bracket data or data frame, and the mapping AES. Under this we now put all our mappings, the aesthetics, the x, the y, and if we want to also add other mappings to it, then we put it here. And then we have the jump. As you can see here, we are using the jump points, and this is the empty cast data frame that it uses. As you can see in this data frame, we have so many variables, but what you just need is just two variables, and that is the display and the mpg, to be able to create this scatter plot. As you can see, ggplot is actually very easy and straightforward. Now let's see how we can customize this scatter plot. Customization in the way that we can put a color there, we can put a label there, and also do many more formatting. For example, as you can see, my plot here is having a gray theme. As you can see, this is gray, but now when it comes here, it becomes white because I use the following code. The ggplot2, in it we have my data, I put my aesthetic there, I use the jump point, and I also add other layers. Remember, I have the data frame. Now this is the code that gives me this plot. Now let me explain it. As you know, before we have ggplot, then the data is our empty cast. That's what we have here in data frame, and in the aesthetic mapping we have display for the x-axis, the mpg for the y-axis, and plus, that is the plus operator to help us add this jump. And here now I use the jump point to give me this scatter plot. And because I want to customize this plot, then I added the labs function. Under this we have the title, that is the title of our scatter plot. As you can see here, I'm saying engine display versus miles per gallon, and that is what we have here as the title of this scatter plot. Then for the x-axis, I have this x is equal to displacement, as you can see, and that gives us this. Then for the y, here now I put this label there, miles per gallon, and that is what gives us this y-axis title. And then because I don't like the theme that I have here before, that is the default theme that always come with ggplot2. In this case, I use what is called theme minimal, and that is what helped me to have this publishable plot. As you can see, this plot is actually fine. So now let's see how to create a bar chart using ggplot2. Also, I will follow the same semantic component, the data, and in this case I want to use the pipe operator. As you can see, after my data frame, I start with the pipe operator, then I continue with ggplot2 functions. Here I use ggplot2, and then under the aesthetic I will put all my aesthetic there, and then I continue with the plus operator rather than the pipe operator. So here I put the plus operator so that I can have my jump function. Then to also add other layers, I will continue using the plus operator. So if I follow this style, I will have this bar chart, and this is the code that produces this bar chart. Now let me explain it. So here I have the data frame because I'm using the pipe operator, to pipe my data frame with the ggplot2 functions. So I have this empty cast as my data frame, then I have this pipe operator, then I continue with ggplot2 functions. Here This is ggplot2, and under it I have this aesthetic function so as to have my other variables inside it. Here I have x to be carb, I have fill to be carb. So the fill here is what gives me this color. As you can see, it tries to give every bar a separate color. Then I have jump bar. The jump bar is what gives me this bar plot. Then I have the labs. In this labs, I put my title, the x-axis and the y-axis so that I can have everything relabeled. In this case, my title is number of cars per carburetor count. And that is what is shown here. Then in the x-axis, I have number of carburetors, and that is what I have here. Then in the y-axis, I have number of cars, and this is what I have here. Then for the theme, I use theme minima. There are a lot of themes that you can use. As you get to the practical session, I will be showing you different themes that you can use. So if you run this code, you have this exact plot that I have here. One thing you should note, when you are using both the pipe operator and the plus operator in ggplot2 is that you use the plus operator to add the jumps and other layers other than the pipe operator. Now let's see how to plot a chart using a base R graphics. Data visualization with base R graphics offers a built-in approach that requires no additional packages. While ggplot2 provides extensive flexibility and elegance, base R graphics remain indispensable for quick, efficient exploratory analysis and the creation of simple static plots. Base R uses a function-based approach, giving you direct control over basic graphical elements without the need for layer syntax like ggplot2. Why should you use a base R for plotting? Base R offers a streamlined, dependency-free environment that is both quick and simple, giving you full control over your data analysis. 1. No dependency. Base R plotting functions are part of the core installation, meaning no extra packages are required. 2. Quick and simple. It is perfect for exploratory data analysis and when fast visualizations are needed. 3. Full control. You have direct access to low-level graphical parameters, which allow for highly customized plots. Now let's see several core plotting functions in this base plot. Base R provides several plotting functions that allows you to create a variety of graphics without relying on external packages. The main functions include plot. That is a generic function that can produce scatter plots, line chart, and even more. We also have the hist function. This is used specifically for creating histograms, ideal for visualizing distribution. We also have the box plot. The box plot function generates box and whisker plots, summarizing distribution of a variable. Then we also have the bar plot function. This helps you to create a bar chart for categorical data. Then we also have the pie function. The pie function illustrates proportion using a pie chart. Now let's see how to customize a base plot function in R. Customization in base R is achieved through a range of built-in graphical parameters or by using the par function for global settings. Key parameters include col for color. This sets colors for points, lines, bars, and text. You can specify colors by name, numeric code, or hexadecimal value. We also have the PCH for point symbol. The PCH chooses different symbols, for example, circle, triangles, etc. for point in your plot. Then we also have the LWD and LTY for line width and type. This adjusts the thickness and the style of lines such as solid, dashed, or dotted. We also have CEX for scaling of element sizes. This changes the size of points and text to improve clarity. We also have main, xlab, and ylab for axis and label. This provides descriptive titles and axis label, which gives you good content for your plots. We also have the par for margin and layout. This controls overall plot appearance by adjusting margin, text orientation, and layout. For example, dividing the plot area into multiple panels, such as we did by using facet in ggplot2. Now let's see how to build a scatter plot using a base R function. In this case, we will use the plot function, and in it we will specify the vector for the x-axis and the vector for the y-axis. As you know, here we have a data frame, and to get a vector from a data frame, you can use a dollar operator. Here I use the dollar operator, and there I select the variable for my x-axis the same way I did for the y-axis here. And this one is choosing what is called XY plotting style. You can also use another style which I'm going to introduce here. As you can see here, is choosing a formula style. Now this is the y variable, and I use the correct sign here, and then I have the x variable called display. Then I put comma here, and I use the argument data to specify that I'm using the empty card data set to plot this chart. When you read several textbooks, they may have it done in this way or by using the formula style. Both will create a scatter plot like this. Now let's see how to customize this scatter plot in base R. To customize this scatter plot, we can use additional arguments such as the main, the x lab, y lab, and the pch for point symbol. Here now, my heading, that is the title of my scatter plot, is engine displacement versus miles per gallon, and that is what I have as the title of my chart. Then I also have the x lab, and that is to rename the title of the x label. In this case I have displacement, and that is what I have here. Then for the y axis, to rename that label, you can also use y lab. In this case I call it miles per gallon. And then because I want to increase the point symbol for this and change it from a circle to a square, then I have the point symbol to be 19. So it has different numbers from 1 to maybe to 20. So then you can just include the number you want here, and then you have it in this way. Then I'm saying that the color for this point should be dark blue, and that is what I have here. Now you can see that we only use just the plot function to have all these things done. The same way can also be done for the bar chart. Now let's see how to build a bar chart using a base R function. To create a bar chart in base R, in this case you need to tabularize your categorical variable. For example, I'm using table so that I can have this curve to be in a table. Then I now use a bar plot for it. As you can see, bar plot bracket table empty cars and curve. So this is a vector of the curve, so as to get the distribution of that curve in a table. And then I now use bar plot so that I can have this visualization done. And how I did it is that first I title my bar plot to be number of cars by carburetor count. Then I have the x lab, that is the x-axis label. In this case I call it number of carburetors. Then I have the y lab to rename the y-axis. In this case I call it count. Then I want all the bars to have the same color. In this case I specify call to be sky blue. That is why, as you can see, all my bars here are having the sky blue color. And that is how to create a bar plot. It's very simple, just one function called bar plot. And in that case you need to tabularize your categorical variable. Then you continue using all the other arguments of a bar plot, such as the main to create a title for the bar plot, the x lab to rename the x-axis, the y lab to rename the y-axis, and color to color the bar plot. Now let me walk you through how to practicalize this thing with the real world data set. Our practical session will be in two categories. One, we will explore data visualization with ggplot2. Second, we will also visualize data by using the base graphics. We will work with 5 different data sets that are ideal for creating visualization. The first one will be empty card data set, the ID data set, the diamond data set, the economic data set, and the art data set. All of this is what we put together to visualize our data set. And from there, you understand how to work with both ggplot2 and the base graphics in R. To follow along this project, first you need to create a directory called database. In that directory, that is where you now create your RStudio project. First of all, create that directory called database, and after that go to the LMS and download this data called data directory. As you can see, in this data directory, I have diamond data set, it's a spreadsheet file. I have art data set, it's also a spreadsheet file. I also have US economic data set, this one is a CSV data. Then after this, then you now create an RStudio project on this existing folder. So let me show you how to do that. First, open your RStudio. So my RStudio is launching. Okay, here I have my RStudio. So what you will do now is to create an RStudio project, and you can do that by clicking on this icon. So as you can see, the new project is loading. Then click existing directory, and from there go to your desktop or wherever you created the directory called database. So for me, I have it on my desktop. So I will go to my desktop and then look for database. Here is the directory, as you can see. Then I will not click on the data because the data is on the LMS and you have to download it and put it on the database directory. So in this case, I have done that. But where my RStudio project will be is the main database directory, which is where I am now. Then I will now click open. Then I will now click on create project. After this, you will see that this one will close and my RStudio project will be launched up. Now I have my RStudio project launched up. As you can see, now this is my data directory. I have diamonds data set, I have art data set, and I also have US economic data set. Then what I will do next is to create an R script where I will write all my codes. In this case, I can come over here and click R script. Then I can rename this R script to be, let's call it database project script, for example. Then I will click save. Now that our project is set up, the next step is to import the packages we will use. First, we import packages like tidyverse, read excel, import df, janitor, and bulk reader package. So let's load the tidyverse package. And we can do that by using library tidyverse. Tidyverse is a collection of R packages designed for data science, and it offers tools for data manipulation, for example, dplyr and tidy data frame with tidyr package, and for visualization with ggplot2. The next package I would like us to load is library read excel. This is a user-friendly package for importing Excel files. It simplifies the process of reading spreadsheet data without requiring any external dependency like Java. Then the next library I would like us to import is library inspect.df. Inspect.df. This package provides a suite of functions to quickly inspect and diagnose the structure and quality of data frames. It facilitates the identification of data types, missing values, and other attributes, helping with data cleaning and exploratory analysis. Next, we will load the library Janitor. Janitor is a toolkit for data cleaning in R. It includes functions to clean column names, making them consistent and syntactically valid. It can also be used to create tables and carrying out other routine for data cleaning tasks, making data sets more manageable for analysis. Then the next library I would like us to load is library bulk reader. Library bulk reader. This package is designed to efficiently read multiple files at once. It streamlines the process of importing large collection of data. It is also particularly useful when working with datasets that span many files or when processing bulk data in various formats. For example, if you open this data directory, you will see diamond Excel file. Just click on it, click view file. So Excel will open it, for example, so that you can see what the data is all about. Now you see that this data span across many shades: fair, good, very good, premium, and ideal. Now to import this kind of data is actually very challenging. The first step is to import it one by one and then append all data sets at once. And that is what bulk reader is trying to solve. The bulk reader function will automatically import all the data sets and also append it automatically with just one line of code. And I will show you when we get into the importing the data set. Now it's your turn to answer the following multiple choice questions on ggplot2 and basic graphics. The first question is, which ggplot2 function is used to create a scatter plot? A. Jump point, B. Jump line, C. Jump histogram, and D. Jump box plot. Second question, in ggplot2, what is the primary purpose of the AES function? A. To add a new layer to the plot, B. To specify the static mappings between data variables and visual properties, C. To set the plot themes, and D. To define the plot's coordinate system. The third question is, which function is used in base R to create a scatter plot? A. Plot function, B. Scatter plot function, C. Point function, and D. Lines function. Question 4. In which function in base R is used to create a box plot? A. Box plot function, B. BP function, C. Plot.box function, and D. B.plot function. Question number 5. In the plot function, which argument is used to change the point symbol? A. PCH, B. CEX, D. COL, and D. LTY. In the next video, we will import all data sets, the spreadsheet files, and the CSV file. Then we begin data visualization with ggplot2. I hope you enjoyed this video. See you in the next video. Bye bye.